Here we're asked to solve for each of the following equations for the variable k. So we're going to need to know our exponent rules to deal with all these problems here. And so I'm just going to go ahead and rewrite this. 5 times 3 to the power of x plus 2 equals k times 3 to the power of x. So what I notice here is that I see 3 to the power of x. There's also like a 3 to the power of x here, except there's this plus 2. So what I'm going to do is I know an exponent rule that will separate these two things, which would make this 3 to the power of x times 3 to the power of 2. And now I'm going to go ahead and kind of put the whole number terms that don't have any variables in it together, because with multiplication I can rearrange this however I want. So 5 times 3 to the power of 2, which is 9. And so that would be 45 times 3 to the power of x equals k times 3 to the power of x. Now I can kind of divide both sides by 3 to the power of x, because that will cancel. And then I can see that for the first one, k is equal to 45. Second one here, I'm going to do the same idea. So I'm going to break it up. 6 times 2 to the power of x times 2 to the power of k equals 24. Equals 24 times 2 to the power of x. Then I'm going to go ahead and divide both sides by 2 to the power of x, because again, I want to get rid of that variable here. So divide both sides by 2 to the power of x, because that will get rid of this. It will also get rid of that. Leaves me with 6 times 2 to the power of k equals 24. And then from there, I'm going to divide both sides by 6. And that will give me 2k equals, 2 to the power of k equals 4. And then I know change of base 2 to the power of k equals 2 to the power of 2. And so I know k is equal to 2 for the second one. Give myself a little bit more space for the last one here. Again, going to use the same types of rules and things to try and get rid of this here. So first one, I'm going to go ahead and divide both sides by 10, because I want to try and simplify this as much as possible here. So now I have 2 times 2 to the power of 3x minus 1 equals k to the power of x. Now I'm actually going to do the reverse of what I've been doing before. I'm actually going to put these together, because I know this is 2 to the power of 1 times 2 to the power of 3x minus 1. And so I can actually put those together, which would be technically 2 to the power of 3x minus 1 plus 1, but negative 1 plus 1 is just 0 and leaves me with this here. Another way to do that, let me just, because I don't want to confuse people, another way to look at this here to simplify, right? This is 2 times 2 to the power of 3x, and then subtraction would be dividing by 2. And so then when I multiply this together, right, the 2 divided by 2 cancels out and leaves me with just 2 to the power of 3x. So a couple ways to do that, but either way, you should be kind of getting rid of that minus 1 in the exponent, and that will also get rid of that 2 in the front. And now I'm going to use power of a power rule, because this would be 2 to the power of 3, and 2 to the power of 3 is 8. And so I know our k value is equal to 8.